Okay, thank you. And the result is correct. So a here is -6 and c equals a squared, which is 36, right? Okay. Okay, any questions here? Okay, let's have a look at question 3. I'll leave your solutions here, okay? This is question B. And question 3, find all solutions to the equation x squared plus 4x minus 7 equals 0. So this is a typical quadratic equation, right? You can either solve it by completing the square method or directly using the quadratic formula, right? So let's show both of the two methods. So method 1 is called completing the square. So remember that we can use the formula a plus b squared equals a squared plus 2ab plus b squared, right? And by observation, we can find that we have x squared plus 2ab. 4x is 2 of 2x and multiplied by 1, right? So this is, sorry, 4x is 2 times x times 2, right? So this is our a and this is our b, right? So we need b squared, which is 4, right? So by using the completing square, we need to put a constant term 4, right? And because there is no constant term 4, so we need to subtract it in order to make the equation equivalent and copy the rest of the equation here. So this equation is equivalent to the original one, right? Can you see that? And by rewriting it like this, we can use the formula in the first part of the equation. So x squared plus 4x plus 4 is x plus 2 squared, right? If you verify this by expanding it, you will find x squared plus 4x plus 2 squared, which is 4, which is exactly the first part, right? So remember that you can always verify by expanding it. And then minus 4 minus 7 is minus 11, right? And this equals 0. So next step, x plus 2 squared equals 11, right? And if you have a number squared is 11, that means this number here must be negative or positive square root of 11, right? And therefore, our solution is x can be minus 2 positive or negative square root of 11. You see that? Okay, so I'll write method 2 here. Method 2 is directly using the quadratic formula. So what is the quadratic formula? Can you still remember that? For a quadratic function in the form of ax squared plus bx plus c equals 0, where a is not 0. This is a quadratic formula, right? quadratic equation. So for this equation, the solution, the determinant delta is defined as b squared minus 4ac, right? This is called the determinant. And our solutions is given by this formula, which is x equals 2a is the denominator, right? And numerator is minus b positive or negative square root of delta. You recall this? Okay, then first, let's calculate delta. Delta equals b squared minus 4ac. So this is our b, right? So 16 squared minus 4 times a. A apparently is 1, right? And multiplied by c. C is a constant here, which is negative 7, right? Okay, so let's calculate. This is actually 256 plus 28, which is 284, right? Am I correct? 2a. Okay, let's calculate this. Oh, sorry, I made a mistake here. This is not 16 squared. This is 16, right? This should be b squared is actually 4 squared, right? Not 16 squared. So 16 plus 28. This is 44, right? Okay, and the solution according to the formula is denominator is 2a, which is 2 by 1, right? A is 1. Negative b is negative 4, and then positive or negative square root of delta. Delta is 44. So this can be simplified to minus 4 positive or negative 4 times square root of 11 over 2, right? And this is negative 2 positive or negative. Sorry, this is not 4. This should be 2. 11, which is exactly the same as the method 1. Okay. Please have a look at this. Any questions? Let me know. Okay. And if you haven't done this correctly, please correct it by yourself. And let me know if you finished. All right, let's have a look at the next one. Question 4. Solve each of the following equations by completing the square. So this question specifically asks you to solve by completing the square. So let's have a look at, remember that completing the square means you can use this formula, right? A plus b squared is a squared plus 2ab plus b squared, right? So in question A, we have x squared minus twice of x and 1, right? This is our 2ab. A is x, b is 1. So we need b squared, which is 1 squared, right? And because there is no 1 squared, we need to subtract it to make it equivalent to the irrational equation, and then copy the rest of the equation. You understand? And then the first part can be rewritten as x minus 1 squared, right? And then minus 1 minus 15. If you're not sure with your transformation here, remember that you can always verify it by expanding it. If you expand it, you will get x squared minus 2x plus 1, and then minus 1 minus 15. So these two cancels with each other, and it will get x squared minus 2x minus 15, which is exactly the same with the left side of the original equation, right? So that means our transformation here is correct. Do you understand? Okay, so the original equation is equivalent to the new equation here. So this means x minus 1 squared equals minus 16. Put it to the right side is positive 16, right? So that means something squared is 16. So something here is positive or negative square root of 16, which is 4, right? And this means x equals 1 plus or minus 4. And therefore, there are two solutions. So remember, if you have a real solution here without the square root symbols, usually we'll calculate the final solutions. So if you choose positive sign, you will get x equals 5. Or if you choose the negative sign, you will get x equals 1 minus 4, which is negative 3, right? So there are two solutions, which are 5 or negative 3. And then let's have a look at question B. Question B, remember that this is our a squared, right? And this is our 2ab. So can you tell me which term you should make up to complete it as a square? Which term we are missing here? The number, yes. What exactly the number is? Number should be b squared, right? So what is that number? Can you figure out 1? Okay, you think it's 1, right? So if you put 1, you will get x plus x plus x squared plus x plus 1, right? Is this a perfect square? No, because if you think it as x plus 1 squared, you will get x squared plus 2x plus 1, not x here, right? So any other thoughts? So remember that this is our a square. This is our 2ab, right? So x is actually 2ab. A is x. And the other number must be 1/2, right? X equals 2x times 1/2. So the other number is 1/2, right? And we're missing 1/2 squared. You understand? You can use x plus 1/2 squared. if you expand it, you will get x squared plus 2ab. 2ab is x, and then plus b squared, which is 1/4, right? So we're missing 1/4 here. If you plus 1/4 and then minus 1/4, and then copy the rest of the equations, new equation should be equivalent to the original one, right? Can you follow me? Okay, so I'll ask you a question here. So for the first part, there is no doubt we put x squared plus x, right? So what is the term here? To make the first part is a perfect square. So what number should you put here? Okay, you think it's 1/2. So let's put 1/2. And then because there's no 1/2, you need to subtract it, right? And then copy the rest, plus 1 equals 0. And now you think the first part is a perfect square. So what perfect square should you write? Should it be like x plus 1/2 squared? X minus 1/2, okay? So let's try x minus addition, okay, addition. X plus 1/2 squared, right? If you think the completing square is like this should be x. If you expand it, you will get x squared plus 2ab, which is x, right? And then plus 1/4. There is no 1/4, right? Because you put 1/2 here, not 1/4. Can you see the mistake? Yes. So what number should you put here? You should put 1/2 squared, right? Because we need b squared. Remember that this term is b squared, not b, right? Yes. So because there is no 1/2 squared in the original equation, if you put 1/2 squared, then you need to subtract it, and then copy the rest of the equation to make it equivalent to the original equation, right? Okay, so following this logic, now we can use completing the square. For the first part, we have x plus 1/2 squared, right? And if you verify it again, you will get x squared plus 2ab. 2ab is x, and plus b squared, which is 1/4, right? And 1/4 is your term here, right? So that means the first part can be rewritten as a perfect square, which is the sum of x and 1/2 squared. And then copy the rest of the equation. Minus 1/2 squared is 1/4, right? And then plus 1, and then equals 0, right? Okay, so next step, x plus 1/2 squared. And then minus 1/4 plus 1 is plus 3/4, right? So what is the next step? Next step, we can just put the constant to the other side. So x plus 1/2 squared equals negative 3/4, right? Then you have something squared is a negative number. So remember there is an I involved in there, right? So x plus 1/2 is positive or negative square root of negative 3/4, right? And that means x plus 1/2 equals positive or negative square root of 3/2i. You see that? Because if you verify square root of 3/2i positive or negative, if you verify this number squared should equal -3/4. Okay, remember that you can always verify your result. Okay, so that means for x is -1/2 positive or negative square root of 3/2i. Okay, so this is our final solution. Right, so please have a look at this and try to correct it by yourself and let me know if you finish, all right? Okay, let's have a look at the next one. Next one, use the quadratic formula to find the solutions to each of the following equations. So we can directly use the quadratic formula here. And if you're not familiar with that formula, I strongly recommend you to explicitly list all the coefficients. So for the first question here, A is 1, right? So A is here, right? So apparently A is 1 and B is 5 and C is 4, right? Plus AX squared plus BX plus C, right? So that means we have our 3 parameters here. Then you can use a quadratic formula. First, let's calculate the determinant delta. Delta is B squared minus 4AC, and then you can just put the numbers in, which is 25 minus 4 times 1 times 4, right? Which is 25 minus 16, which is 9, right? So delta is 9. Therefore, according to the quadratic formula, our solution x is denominator is 2a, which is 2 by 1, and then minus b, which is minus 5, and then positive or negative square root of delta, right? Delta is 9. So this is our solution, which is -5 plus or -3/2, right? And therefore, if you choose positive sign, that's -5 plus 3, which is -2. -2/2 is -1, right? So x can be -1. Or the other solution is if you choose negative sign, this is -5, -3, which is -8/2 is -4, right? The other solution is x equals -4. Understand? Okay, and let's try to solve question B. Again, first of all, let's convert it to the standard form of quadratic formula. That means put everything on left side, right? So r squared original equation is equivalent to r squared minus 3r minus 7 equals 0, right? And then what is our a? A is coefficient of the leading term, right? Or a is the leading coefficient, which is 1. And b is, tell me what is b here? No, the standard form of quadratic formula is ax squared plus bx plus c equals 0. This is called standard form, right? So this b is the coefficient of x. So b is -3, right? What is c? C is a constant, right? So c is -7, correct? Pay special attention to the 3 parameters here, because if you can't get them right, if you can't get them right, you cannot use a formula correctly, right? So be careful with the 3 values here. All right. So once you have all 3 parameters, then we can use a quadratic formula. First, let's calculate the determinant delta. Delta is b squared minus 4ac. Remember that? And b squared is 9. 9 minus 4 times a, which is 1, times c, which is minus 7. So this is 9 plus 28, right? Which is 37. Okay, so delta is a positive number. That means we should have 2 different real roots. Understand? And according to the quadratic formula, x equals the ratio, right? The denominator is 2a, which is 2 by 1, and then minus b, which is 3. Then positive or negative square root of delta, which is 37, right? So there are 2 solutions. 3 plus or minus square root of 37 over 2. Because 37 is not a perfect number, so we can just leave it like this, okay? Any questions? Okay. So I hope next time you can solve similar questions by yourself, okay? I think the next assignment, we should practice one more time using similar questions. Okay, question 6. For what values of constant k does the quadratic equation 3x squared plus 4x plus k have real roots? So in what situation this quadratic equation have real roots? We need to calculate the determinant, right? So can you tell me what conditions under what conditions the determinant should be in order the quadratic equation have real roots? There are 3 options. Either the determinant is greater than 0 or equal to 0 or less than 0. So in which of these conditions the equation will have real roots? Greater than or equal to, right? In these 2 situations, the quadratic equation will have real roots. That's correct. And in the last condition, the quadratic equation will have 2 imaginary roots, right? Okay, so that means we can write like this. The quadratic equation has real roots is equivalent to the determinant delta is greater than or equal to 0, right? Which means, so tell me how to calculate the determinant. Determinant is b squared minus 4ac, right? Remember that? So b is 16, right? And minus 4 times a is 3, and c is k, right? And this is a determinant. We have just discussed the determinant must be greater than or equal to 0, right? So that means k must satisfy this condition in order the original equation has real roots. So that means 16 minus 12k must be greater than or equal to 0, which means 12k must be less than or equal to 16, which means k must be less than or equal to 16 over 12, which means k must be less than or equal to 4 over 3, right? And this is our final solution. That means when k is less than or equal to 4 over 3, the original quadratic equation will have real roots. Okay, so please spend some time to correct your solutions and let me know if you finish. Okay. All right, let's have a look at question 7. Question 7, any thoughts? Final solutions to the equation. A ratio equals 1. That means if we multiply both sides using the denominator here, we can convert it to 2 equals 3x plus 5 over x, right? And then when x is in the position of denominator, usually we don't like this, right? So we can multiply both sides using x, correct? But before we do that, we need to ensure that x is not 0. So when x is not 0, we can multiply both sides using x. So that means 2x equals 3x squared plus 5, where x is not 0, right? That means the original equation is equivalent to this one. We can only solve this one. So this is equivalent to 3x squared minus 2x plus 5 equals 0, where x cannot be 0, right? And then we can just directly use the quadratic formula, right? Where a is 3, b is minus 2, and c is 5, right? So our determinant delta is b squared minus 4ac, which is 4 minus 4 times 3 times 5, which is 4 minus 60, which is minus 56, right? So note here, minus 56 is less than 0. So pay special attention to this case. That means we need to solve this equation in the complex number domain. You will have imaginary solutions. Okay, so the solutions according to the formula is a ratio. Denominator is 2a, which is 2 by 3, right? And then the numerator is minus b, which is 2. And then positive or negative square root of delta, which is minus 56, right? So can you tell me, what is square root of minus 56? You need to calculate this first, right? Okay, I'll write it here. What is minus 56? Square root of minus 56. Okay, 4 square root of 3. You mean we can put the equality sign here, right? All right, so okay, I'll change that to twice of square root of 14. Okay, that means my question is, can we put equality sign here? Did you miss something? Did you miss anything? Remember that you can always verify by putting a square to both sides, right? No, I mean, forget the positive or negative sign here. First of all, we'll calculate the square root of negative 56. Okay, if you square both sides, are they equal? Can you verify that by yourself? Verify that by yourself, and then you'll find what you missed. They are? Okay, let's verify this. So negative minus 56 squared. This is left side, right? So this is negative 56, right? This is our left side. Okay, this is our left side. And what about right side? Right side is twice of square root of 14. If you square it, you will get 4 by 14, which is positive 56, right? Negative 56 is not equal to positive 56. So what you are missing here? No, I mean, you just claimed that negative 56 equals twice of square root of 14, right? And you want to put a negative sign. Where do you want to put it? Here? Here. Okay, you want to put it here, right? And then you need to calculate what is square root of negative 14. So how about instead of putting a negative sign here, we put an I. So that means square root of negative 56 is a imaginary number, which equals twice of square root of 14 times I, right? And if you verify this by square the left side, you will get negative 56. And by square the right side, you will get 4 times 14 times I squared. I squared is negative 1. So this is also negative 56, right? Remember, using the imaginary unit I, you can eliminate the negative sign under a square root, because usually we don't write numbers like this. We need to put the negative sign outside the square root symbol. You understand? Okay, so can you tell me What are the solutions now? Okay, we just took a detour, and let's get back. X is, denominator is 6, right? And numerator is 2, negative or positive. Which number should I put here? So 2 times 14 times I, right? Am I correct? Okay, so usually we don't write it like this. We put 2i in front of the square root symbol. This is a common way we write a complex number. Okay, can you follow me? Okay, and then we can cancel a 2. So the final solution is 1 positive or negative I times square root of 14 over 3. You see that? Okay, so please spend some time to correct your solutions, and let me know if you finish. And I forgot to mention that all the steps following this step are based on the assumption that x cannot be 0, right? So again, you need to verify if your solution here is 0. If it is 0, it will contradict the assumption here, right? So at last, you need to verify if your solution here is 0 or not. So luckily, x is a complex number here, which is not 0. So that means our solutions here are correct, which are not contradictory to the assumption here. You understand? Okay. All right, let's see the final question here. Let R and S be the roots of the quadratic x squared plus bx plus c, where b and c are constants. If the product of R minus 1 and S minus 1 equals 7, find sum of b and c. Okay, so there's a special trick I need to mention. Remember that the quadratic formula states that for a quadratic function, a quadratic equation ax squared plus bx plus c equals 0, there are two solutions, right? Two solutions are given by the quadratic formula. X1 is minus b plus square root of delta over 2a, right? And the other solution is minus b minus square root of delta over 2a, right? Where delta is b squared minus 4ac is called the determinant. And you can see that the sum of the two solutions is actually minus b plus square root of delta over 2a plus minus b minus square root of delta over 2a, which is actually minus 2b over 2a, which is minus b over a, right? You understand? The sum of the two roots always equal minus b over a. You understand? Okay, and there is another conclusion. The product, how about the product of the two roots? Product of the two roots is minus b plus square root of delta over 2a times minus b minus square root of delta over 2a. Can you tell me what is the product of the two roots? And note here the delta is actually b squared minus 4ac. So can you calculate the result? Tell me what should I put here? Okay, if you calculate this, the denominator is 4a squared, right? And numerator is b squared minus 4ac. And after simplification, what should we put here? This is 4ac over 4a squared, right? And 4 canceled with 4a canceled with a because a is not 0. So we should put c over a, right? Can you follow me? Okay, so that means the quadratic formula also tells us that the sum of the two roots always equals b minus b over a, and the product of the two roots always equals c over a, right? Do you understand? Okay, so we can use this conclusion to solve a question like this. Because R and S are roots to this quadratic equation. So that means the sum of the two roots always equal minus b over a, right? Which is minus b over 1, which is minus b. And the product of these two roots always equals c over a, which is c over 1, which is c, right? Can you see that? Because R and S are two roots to this quadratic equation. That means we have these two conclusions here. And also we have this function, this equation here. This equation is equivalent to, if you expand it, you will get Rs minus S minus R plus 1 equals 7, right? Which means Rs minus the sum of S and R equals 6, right? And the product of R and S is actually C. So this is equivalent to C minus the sum of R and S is minus B, right? So minus B, and this is 6. And this actually tells us that C plus B is 6, right? Which is what the question asks us to find. So B plus C is 6. You follow me?
For me.
Okay, so please spend some time to correct your solutions and let me know if you finish, okay? All right, so the last question, I'll put my lecture notes to Google Classroom for you to refer to. And I'll let you know when the next assignment is available on Google Classroom, okay? First of all, let me upload it. up there. And if you do not have any questions, I'll see you next time. Okay, I'll let you know when the next assignment is available. Okay, have a good night.